Hello everyone and welcome to the YouTube channel of BeingACCA. This is Tushita Gupta, ACCA affiliate, and we are continuing with the chapter-wise revision. This is chapter number 11, quantitative techniques. Let's get started. So, this chapter gives you a lot of ways of a lot of quantitative techniques, as the name suggests. So, the first technique that you would have also learned in your MA exam is the high-low analysis. So this high-low analysis is basically a method wherein you can analyze your semi-variable cost into fixed and variable. So probably if you have a component like this is your total cost, so this analysis is going to allow you to have the breakdown of what part of this cost is fixed and what part of it is variable. So semi-variable cost can be broken down into fixed and variable elements based on an analysis of historical information about costs at different activity levels. Now, there are a few advantages that this analysis gives you. So, one of the advantages is that it has the enormous advantage of simplicity. It is very simple. Just a plain simple formula is going to help you a lot. Second advantage is that it is easy to understand and use. Easy to understand and use. Now, nothing in the world comes with only advantages. There are always disadvantages. So, let's talk about the disadvantages of this method also. First of all, it assumes that the activity level is the only factor which is affecting the cost. So, activity level assumption, right? Assumptions will more or less be the disadvantages. Second disadvantage, it assumes that your historical costs can reliably predict the future costs. What has happened in the history, is reliable information to predict future costs also. That is what it presumes. But, this might not be the case. We are living in a very dynamic world. So it may not be the case. Predict future costs. Now, another disadvantage can be the fact that results may be distorted due to random variations in highest or lowest values. So, what happens is using the high to low method, maybe these are my activity levels. So, I'll be taking the highest one and the lowest one. So, if there is something, a random variation in either this or this level, it's going to give me a distorted result. Distorted results, right? So these are the disadvantages of the high-low analysis. Now we are moving to the second quantitative technique under this chapter. This is learning curve. Now, when it comes to learning curve, what do we mean by this? It's basically a mathematical expression of the commonly observed effect that, whenever you are repeating something which is a process, which is complex and it is labor intensive, that means, it's less of machinery work and more of manual work. So, if this is repeated, the unit labor times tend to decrease. So what happens is, if I am doing one sort of work and I continue to do this every day, day by day, what's going to happen is, probably the first day I will take 8 hours, maybe next day, because I have learned out of this, I will take 6 hours, and probably the next day I'm only going to take 4 hours. So what happens is, as and when I'm repeating one thing again and again, I'm learning something every time. So probably there's some things involved which, because of doing it over and over again, I am, discovering ways to do it faster, do it efficiently. So that is how the unit labor time will decrease slowly. So this is what you call the learning curve. So let's also talk about where this is applicable. A learning curve will help you in pricing decisions. It will also help you in work scheduling. It will also help you in product viability, whether or not a product is viable. It will also help you in standard setting. If you know that the labor is going to learn, you're probably not going to allow them the same number of hours that you allow them the first time. Then another thing, budgeting. Definitely, once you set the standards, budgeting can also be done using these standards. So these are the few applications of the learning effect. Again, let's go through the learning effects limitations. So the limitations basically will more or less be the assumptions. You can you also call that these are the assumptions of the learning curve effect. So if I talk about the limitations or assumptions, first of all, it is assuming that your process is labor intensive. So it may not be useful where it's a something which has to be done, which does not involve labor and has to be done more of mechanically rather than manually. Then the product is new, product is complex, and another assumption, this is a big one, that your production is repetitive, and there are no breaks in production. Right? So these are the limitations, or you can say also the assumptions that the learning curve effect has. Now we will move to another quantitative technique in this chapter, which is your regression analysis. Now this is something which, a lot of people are scared of, but you should not be. It's nothing so difficult. Or this can also be called the least squares method. So both of them mean the same thing. Now, the first thing that you know under regression analysis is that, basically the regression line of y on x is used where you estimate, how much where you estimate of y, which is your dependent variable, is given for is required for a given value of x, which is the independent variable. Now, if we talk about where it is used, its uses are, a time series. You will be able to, have a time series once you're doing the regression analysis, and you can also create a trend line. Another thing you can use it for is total costs, where your costs consist of a number of fixed and variable costs. So these are the uses basically. Again, talking about the limitations like we have been doing. So the limitations of this method is that it assumes a linear relationship between the variables. You can also say that these are the assumptions. Linear relationship. That means if something is going to get increased by 1 point, the other thing is also going to get increased or decreased by 1 point, and only measures relationship between two variables. So if there are multiple variables, this will not be useful. Between two variables. Another disadvantage that it has is that only interpolated forecasts tend to be reliable. Only interpolated forecasts tend to be reliable. Another disadvantage, so we have a long list over here. Another disadvantage is that it assumes that the historical behavior continues in the future. So basically, history will repeat itself, continue. Right? Another disadvantage is that predictions are only reliable if there is a significant correlation. And the last point that we talk about over here is that accuracy is reflected by the need to adjust historical data and future forecasts to allow for price or cost inflation. So obviously when you are using historical data to talk about the future, the history did not have as high inflation levels as we have today. So we'll have to adjust for that also. Now there are two terms which you should get familiar with: interpolation and extrapolation. So these are two terms which you will hear in PM. Interpolation basically means if the value of x, the value of your independent variable, is within the range of our original data. So probably my original data was between 101 and uh, let's suppose 150. So if my actual value of x comes out to be 149, so that means this data is within my range, so this will be called interpolation. Now if I talk about extrapolation, exactly the opposite thing. If this remains my range and I have an output of, let's suppose, 170, then this is extrapolation because the value of x is outside the range of our original data. Now if we talk in general, uh, usually interpolation is much safer than extrapolation. Now let's talk about correlation. Let's talk about correlation. So correlation is basically concerned with establishing the strength of the relationship between two variables. How closely are these two variables related to each other? So first of all, always remember that it will be between, the value will be -1 and +1. The value will always lie between these two points. If r is equals to 1, that means there's a perfect positive correlation. That means if x is 1 and y is, let's suppose, 2. So if x goes on to, let's suppose, 2, y is also going to increase by the same number of units. So that means there's a positive perfect correlation. Now, if I talk about a situation where r is equals to 0, then there is no relation. Maybe x is, if x goes 5, then y happens to be still at 2. There is no correlation between them. And there is another scenario where your r will be -1, so perfect negative correlation. Now, let's also talk about the limitations. First of all, correlation and causality are not the same thing. Another limitation is that correlation could be misleading used on sample data. And another disadvantage is that correlation coefficient of 0 could fail to detect an obvious relationship if not a linear one, because this only works on linear relationships. Now let's talk about time series. Time series. So if we talk about time series, there are four kinds of components. First, it can be a basic trend which goes on in the long run, in the long term. Another component is a cyclical variation. This changes with the cycles. So this is medium term. Another one is random variations. Random variations are something which are going to be there in the short term. Another thing that you have is a seasonal variation. This happens due to changes in seasons, and this is short term. Right. So if I have to find out how much the value of my actual data is going to be, it's going to be nothing but the trend plus my seasonal variation. Similarly, I can transpose this formula and also say that seasonable variation will be equal to actual data minus the trend. Now let's also talk about the advantages and disadvantages of time series analysis. So if I talk about the advantages first, number one is that you are able to identify seasonal variations, identifies seasonal variations. Another advantage is that it can be non-linear as opposed to the method that we were learning above, can be non-linear. And another thing is that they are more accurate. The data that you predict with the time series analysis, it's also more accurate. Then let's talk about a few disadvantages also. First of all is the fact that it is a little bit complicated. Another thing is that your seasons may change. Maybe the impact that you're getting as the seasonal variation may not be the same for the next season because seasons may change. Another disadvantage is that it is based on historical data, so may not very accurately reflect what's going to happen in the future. And another point which we can say is that it is less useful in the long term. Less useful in the long term. So these are a few advantages and disadvantages. Now let's come to a conclusion also. We have studied such a lengthy chapter. The conclusion is that your linear regression is most relevant when it comes to linear relationships between the variables. So linear regression is suitable when there's a linear relationship. Another thing is that time series analysis is most appropriate when you have seasonal variations causing curved forecasts. Time series analysis is most appropriate when seasonal variations cause curved forecasts. Now with this we are done with the chapter number 11. We will meet in the next video for chapter number 12. Thank you so much for watching. I hope that this was helpful.